Through the Chapter 4 Test C, just so that you've got something to work from. You can go back and do Test A and Test B. Test A we've already run through in class. There's also Test D. Usually that has a few other more unusual things, so that will be the last thing I'd do. Don't forget the massive revision sheet as well, which had, whatever it was, 118 questions for you to work on as well. So if there's anything you find you're having trouble with, go over to that one and then work on those. If there's stuff you're always getting right, don't bother practicing it anymore before tomorrow. Just work on the stuff that you can still improve. Anyway, question 1 here. The rule for a horizontal line passing through the point -5, 9 is. So a horizontal line, remember every horizontal line, if we have a set of axes here, y and x, every horizontal line has the same y coordinate all the way across. So the line is always going to look like y equals a number. In the other test, you might be asked about a vertical line rather than a horizontal line. And in your test, it could be either as well. Works the same way, except for a vertical line, rather than having the same y coordinate all the way across, it's always the same x coordinate. See how it's going through the same x all the way up and down? So that will always be x equals a number. This one here, horizontal line, it's going through a y coordinate of 9, so it's going to be y equals 9. So that's going to start off with letter E. Alright, the gradient of the line joining the points 3, -2 and 3, 7. So remember, your gradient is your rise divided by your run, which we can also measure as the change in the y coordinates divided by the change in the x coordinates. And if they actually give the coordinates, then we usually go y2 take y1 divided by x2 take x1. Remember, label your points so you don't accidentally do them in the wrong order. x1, y1, x2, y2. So if I substitute those into this rule, y2 is 7 minus -2, and x2 is 3, and x1 is 3. And that's a little bit surprising, because what we're going to end up now is 9 divided by 0. And what does that mean? We can't divide by 0, so the gradient is undefined, because division by 0 is undefined in maths. And that's always the gradient of a vertical line. And if you see, they've got the same x coordinate, so just like I was talking about before, in a vertical line, it's always x equals the same number. Well, here the x equaled 3 in both cases, so it's a line going straight up vertically. That's why the gradient is undefined. The gradient of the line 2x take 3y equals 6. This is a little bit annoying because it's not in our nice y equals mx plus c form, which we can then easily say the gradient's just the number in front of x. So let's rearrange it. I don't want to have -3y, so I'm going to add 3y to each side as my first step. So now I'm going to have 2x equals 3y plus 6. Well, I want to get y on its own, so I'm going to subtract 6 from each side. So 2x takes 6 equals 3y. And finally, opposite of multiplying by 3 is to divide by 3. So everything on the left-hand side gets divided by 3. And if I go 6 divided by 3, that's 2. The gradient is the coefficient of x, the number in front of x. Now, it's not just 2, because it's 2 being divided by 3, it's actually 2/3. So the gradient of that line is 2/3. Which of the following points... Ooh, did I press on my... Pressing something on my tablet there. That looks pretty funny. Radial menu. Can I get rid of it somehow? You can see I haven't done this too often. There we go. Got rid of it eventually. Sorry about that. That was entertaining, wasn't it? Which of the following points does not lie on the line y minus x equals 6? Well, these ones you just test it. 8, that's the y coordinate, minus 2, that was the x coordinate, y minus x, 8 minus 2 is 6, so that works. -7 minus -1 would be -7, plus 1 would be -6. -6 isn't the same as 6, is it? So that's going to be the problem. Checking the others quickly. 23 minus 17, yep, that's 6. 2 minus -4 becomes 2 plus 4, yep, that's 6. 0 minus -6, 0 plus 6 is 6. So we know we got that one right. Midpoint. The midpoint is the average of the x coordinates. Take the 2x coordinates and divide them by 2. And the average of the 2 y coordinates. So it's not the difference between them, like when we're finding a gradient or distance. It's just the average when we're finding the midpoint. And that makes sense because the middle is what an average is. So, make sure you label your points again just so you don't get them confused. x1, y1, x2, y2. And we go ahead and do this. So x1 plus y, x1 plus x2. So negative 7 plus 4 divided by 2. And then negative 3 plus negative 9 divided by 2. So it's going to be negative 3 on 2. And negative 3 plus negative 9 is negative 12 divided by 2 is negative 6. So negative 3 on 2, that's negative 1.5. And negative 6 must be D. Moving on. The length of a line segment. So remember your length, where does it come from? It comes from Pythagoras' theorem. I can find the horizontal distance and the vertical distance. The vertical distance is the difference in the y-coordinates. So this is the point. That's my second point, x2, y2. This is my first point, x1, y1. And I can find the horizontal distance easily enough. That's the difference between the x-coordinates. And then using Pythagoras' theorem, this distance, if I square it, is going to equal the sum of the squares on the other two sides. y2 take y1 squared. But of course I don't want to know what the square of the distance is, so I just square root that, and that's where your rule comes from. And that's how you remember it. If you just draw it and think Pythagoras' theorem, you'll be able to come up with the theorem even if you don't remember it, which is the tricky part. So, what are my points? x1, y1, x2, y2, and it's just a game of fill in the blanks. Really important, even if you get this formula wrong in the exam, but you've tried to do the right thing, and you substitute the points in correctly and do the rest of the working, you will still get some marks. So it's important that you're always showing you're working and making, writing out rules that are easy for me to follow what you're doing, so then I can reward you for the work that you do. So 14 is x2 minus negative 1. So 14 minus negative 1. That's in brackets squared, plus y2 is 2 minus negative 7 squared. So what does that mean? D is going to be, that's 14 plus 1 is 15 squared is 225. And that's going to be 9, and when I square it is going to be 81. So D is going to be the square root of 306. And luckily enough, we don't need to simplify or anything else. They've given us the distance in that form, so that's all we have to do. All right, gradient of a line perpendicular to this one. Well, we know that M2, if we want a gradient of a perpendicular line, that's negative 1 divided by the gradient of the first line, so that's 4 perpendicular lines, right? And we remember that perpendicular means at right angles. But this one isn't in a form where I can see the gradient first, so I've got to get it in the right form, y equals. So that means I've got to divide by 4. So I divide 2 by 4, and I'm going to get 2 divided by 4 is a half. 2 quarters, 1 half. So this equation is the same as a half x minus a quarter. So therefore the gradient of the line perpendicular, I take this gradient of a half, I turn it upside down, and I put a negative in front of it. So it's going to be negative 2. So the negative reciprocal. If I start with a half, turn it upside down, put a negative in front of it, it becomes negative 2. That would be the perpendicular line. Question 8. This line, 2x take 5y equals 8, and x plus d intersect when x equals negative 1. Well, we should be able to figure this out pretty quickly then. So if x equals negative 1, this would be negative 2, because 2 times negative 1 is negative 2, minus 5y equals 8. I can add 2 to each side. I've got negative 5y equals 10, dividing by negative 5, y equals negative 2. So now I can, when x equals negative 1, y should equal negative 2. And I put those numbers into the other equation. Negative 2 would equal negative 1 plus d. If I add 1 to each side, it tells me that D is equal to -1. So answer A. A little bit trickier, that one. Probably more like your assignment work or what we did last chapter, but still able to do it. Intersecting lines, though, that's going to be on your assignment, so don't panic too much if you don't fully understand that one. But of course, you're going to need to know it sooner or later, so learning it now is as good a time as any. Finally, question 9 here. Two cars are 660 metres apart, travelling towards each other. One going 20 metres per second, one going 24 metres per second. If they're going in opposite directions, then the gap is closing. The gap is decreasing by 44 metres per second. 20 from one car, 24 from the other. So if I go 660 metres per second divided by 44, and I think I'm going to get 15 seconds there. So in 10 seconds, it's going to go 440. So another 220 will be another 5 seconds. The lines y equal mx and x equals c intersect at what point? Well, if they intersect, then we already know the x-coordinate, don't we? The x-coordinate's going to be c. So it's going to be c, comma, something. And when x equals c, this expression over here, y is going to equal m times c, isn't it? Because I'm going to replace x with c. Y would equal m times c. So it's going to be c and mc. Again, a little bit abstract, that one. But to find where they intersect, you just let them equal each other. Again, that's more of an assignment question for you guys. That's 11 minutes. I'm going to stop there and then make another video while this one uploads. Catch you for part B soon. Bye.